Welcome. This is Algebra 2, Chapter 5 review. Here we have exercise 17, and we have another polynomial that needs to be factored. Well, as before and as always, one should look for common factors that one can factor out of the entire polynomial before you do any of the hard work. And in this case, a 3 can be factored out of the entire polynomial. And that's nice because it reduces all of the numbers. And that's important because next, with this cubic, we're stuck trying to guess zeros using the rational zero theorem, which means we need numbers that are factors of 15 on top and factors of 1 on the bottom. Now, again, making a list, that means we're talking about perhaps 1 over 1 plus or minus, or 3 over 1 plus or minus, or 5 over 1 plus or minus, or 15 over 1 plus or minus. Now, again, if you look, this could have been worse because the original numbers were 45 for the constant term and 3 for the leading coefficient. Now we just have 15 for the constant term and 1 for the leading coefficient, which again makes our list 1, -1, 3, -3, 5, -5, 15, and -15. Now this is a long enough list. That's 8 numbers that we need to check in our function. The best way to do this, if you have a graphic calculator, is with the table. You should ask me about that. And if you don't, it's not a big problem, but it's just slightly more tedious. You have to try plugging in all the numbers. So you try plugging in 1, and you're going to get -48, and you're going to say, oh poo. But you'll know that that was not a good number. And then you're going to try -1, and you're going to get -24. And again, oh poo, but you know what, that wasn't a good number, and we're making progress on our list. Then maybe you substitute in 3. You don't have to put the numbers in this order, but without anything better to do, maybe that's what you just do. You get 72 when you substitute in 3, and you, in disappointment, just sadly cross off the 3 and knock it out of contention. Then you have -3. When you stick a -3, you get a 0, and then you get this feeling of elation and satisfaction, or at least relief, because then -3 worked. Great. That means we need to go ahead and use synthetic division with -3 on our polynomial now. -3, we're going to synthetically divide into 1x cubed and 3x squared and -5x and -15. Vroom. 1 goes down, multiplies by -3 to make -3, adds to make 0, times -3 is 0, adds to -5 to make -5, multiplies by -3 to be 15, 0 on the end again. This 0 on the end is kind of a confirmation. Happy face. You knew you should have it because you already had it once, but it's good to know. So we had this common factor of 3, the beginning thing. Now, because we have a 0 at -3, we have a factor of x plus 3. Also, we have a factor of x squared minus 5. Now, there's no linear term because of the 0 in the middle here, so it's x squared plus 0x minus 5. Again, you should look at the 3 and x plus 3 and say, yes, done with that part. And you should look at that x squared minus 5 and go, not sure about that. So, unless you know how to factor these things down cold, you might turn to your friend the quadratic formula. You go x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And again, this is the sort of thing you need to know in life to make it through class. X is, now b is 0 in this case, so it's the opposite of 0. You can just write 0, doesn't really matter. Plus or minus the square root. B squared is 0 squared, it's 0. Minus 4, in this case a is 1, and c is negative 5. All over 2 times 1. Okay, so now we're in business because we have x equals 0 plus or minus, and then inside that square root we have square root of 20 over 2. This is not a negative number. It is not a pleasant number because it's a square root and it's not a perfect square. You can't just cross it off and write a nice number. But 20, as you may well know, is really, I'm not going to write the 0 anymore because it's just a 0. But 20 is 2 times 2 times 5. Again, it's still over 2. And so then, because you have a pair of 2's and the square root jail, 1 comes out. And then, after all that, you notice that the 2's cancel. So x is really just plus or minus root 5. There's no more denominator left. So you found the missing zeros. These were not on your list at the beginning because they're not rational numbers. They're irrational numbers. But they're real numbers and we can factor it. So now that we have that information, we are ready to finally factor. We have 3. We have x plus 3. This is from a long time ago. And then, because of the root 5, we have x minus root 5 as a factor, and x plus root 5 as another factor. This is a little bit obnoxious, but it should be entirely possible. You start with common factors, you work through the rational zero theorem, rational root theorem, same thing. You find one that works, you do synthetic division, you divide, you look at your answer, perhaps you would enjoy the quadratic formula, then you use your answers from the quadratic formula to find the way of factoring the end. Thank you for watching.